Hello everybody, I welcome you all in 7th session of your Physics Paper 1 syllabus. In this session, we are going to study sound as a wave. So basically, a sound is nothing but a mechanical wave that results from the back and forth vibrations of particles in a medium. So sound is nothing but a wave that carries an energy, sound energy, from one location to another location in such a way that it allows the particles of the medium to vibrate in back and forth direction. So we can say the motion of particles that carry the sound energy is parallel to the direction of propagation of energy, and thus we say that the sound waves are longitudinal mechanical waves. There is another type, that is tangential waves. We have seen in previous session that a wave in which the motion of particle is parallel to the direction of propagation of wave, we call that waves as longitudinal wave, and sound is a kind of longitudinal wave. When sound travels through a medium, of course there is a change in pressure of that medium in the form of compression and rarefactions. So sound waves are sometimes also called as pressure waves. These are also known as the pressure waves. Now, a question must be arise: how a sound gets produced? The answer is that the sound is produced due to a kind of vibrations. It is produced due to vibrations. For example, if we see the musical instrument veena, we have seen many times that the sound from veena comes by the vibrations on a string. Tabla, we have seen that the tabla, the vibrations in the membrane of tabla causes some sound to come out. In case of fluid, it is nothing but the air column which has been formed in the fluid, and vibrations produced in that air column produce a very pleasant sound. What about my sound that you are hearing now? Our sound is produced due to vibrations of vocal cords that are present inside our throat. And so we can say sound waves are produced due to vibrations. Sound waves are produced due to a kind of vibrations. Now, as sound is a wave, it must have many parameters associated with it. For example, wavelength, frequency, speed, time period, and all. So now, in next slides, we will see what are the important parameters that we must know if we have to distinguish one sound from another sound. The very first thing that we must know about the sound is sound frequency. Sound frequency. We have seen frequency is nothing but the number of oscillations per unit time. So, in case of human being, the audible range of sound, the sound that we can hear, is about 20 Hz to 20,000 Hz. This is the boundary frequencies within which we can listen the sound, 20 Hz to 20 kilohertz. What if the sound is having frequency less than 20 Hz? The sound with frequency less than 20 Hz is known as infrasonic sound, whereas the sound above 20,000 Hz, is known as ultrasonic sound. Infrasonic sound, ultrasonic sound. So, how this infrasonic sound get produced? By which animals? The sound produced by whales, sound produced by elephants, sound produced by a vibrating pendulum is nothing but an infrasonic sound. Infrasonic sound. Even the earthquake, when it comes into action, before that it produces a kind of sound which is in infrasonic range, which is an infra sound. I remember when there was a horrible earthquake in our Killari region, people were saying that at that night before earthquake happened, almost all dogs of the village were barking a lot. Why? Because dog is the animal that can hear infrasound. So these animals heard the sound from earthquake that was in infrasonic range, and as a result, before that huge earthquake, the dogs were starting barking. This is why it is said that few animals get a quick information about some disaster. The ultrasonic sound, that is sound above 20 kilohertz, ultrasonic sound is a sound produced by dolphins, by bat, by rat. These animals produce an ultrasonic sound. This ultrasonic sound is having a very huge applications in medical field and in many other fields, such as the sonography that many gynec use regularly. This sonography is nothing but the use of this ultrasonic sound. Sonars. There are many examples in which we could say that ultrasound is used. As far as frequency of sound wave is concerned, we must remember two terminologies that are mostly used in music, that is a tone and a note. A tone is said to be a sound which consists of only one frequency, whereas a sound that includes several frequencies, we called it as a note. Okay. For example, in case of guitar, when we pluck only a single string, it produces a sound which is of single frequency. We call it as a tone. But in order to get a more pleasant music sound, it is not sufficient to plug a single string. In case we use multiple strings, so that multiple strings produce sound waves of different frequencies, and we will hear a pleasant combination from that frequencies. What we called it as a note. Note. So these are few terminologies that we must remember as far as we are speaking about sound frequency. The next parameter that is well used whenever sound waves are discussed is the sound speed. Is the sound speed. The speed of sound usually is taken to be 343 meter per second. Speed of sound is 343 meter per second at 20 degrees centigrade in dry air. On which factors the speed of sound depends? Because in transverse wave we have seen that in case of transverse wave we have seen that the speed of wave depends on the tension applied to the string as well as it depends on the moment of inertia. Likewise, in case of sound wave, which is a longitudinal wave, the speed depends on two factors, that is the elasticity of medium, that means it depends on medium, as well as it depends on the density of medium. It depends on the density of medium. As it depends on elasticity property of medium, sound at different speed in different medium, such that the speed of sound in liquid is greater as compared to speed of sound in air. Likewise, the speed of sound in solid, such as iron rod, is much greater than the speed of sound in liquid. Now, as sound speed depends on density of medium, whether the medium is rarer or denser, it changes the speed of sound. But density of medium is dependent on the temperature term. As temperature increases, density decreases. As temperature increases, density decreases and speed of sound is varying as 1 by density. Inverse proportion is there. So we can say as temperature increases, the density decreases and the speed of sound also increases. The speed of sound in density decreases and speed of sound increases, right? Thus, speed of sound is directly proportional to the elastic property. For example, if it is a solid material, it is proportional to Young's modulus of that medium. And sound speed is inversely proportional to the density. Or we can say sound speed is directly proportional to temperature. So these are the two factors on which speed of sound depends. Now, as far as sound speed is concerned, we must remember or we must know the two terminologies, that is a supersonic speed and subsonic speed. So whenever we heard the speed of jet aeroplane, we heard few words like it is traveling with a supersonic speed. Wow! So what is mean by supersonic speed? A supersonic speed is nothing but a speed which is greater than the speed of sound. For example, in dry air at 20 degrees centigrade, whatever speed greater than 343 meter per second, that speed is termed as a supersonic speed. Whereas a speed less than the speed of sound, it is termed as subsonic speed. Subsonic speed. Usually, it is the parameter Mach number that is used to state whether the speed is supersonic speed or subsonic speed. Mach number is greater than 1 if it is a supersonic speed. Mach number is a fractional term, 0.5, 0.6, 0.7, 0.99, like this. So Mach number is a fractional term for a subsonic speed. Mach number is 1 for a sonic speed, that is speed of sound. So these are two terms that are related with the sound speed. Now apart from the speed and frequency that are the usual parameters associated with any wave, there are few more parameters that are very special in case of sound waves. And what are the parameters? So let us see one by one. The very first parameter is nothing but the intensity of sound. Now we have learned physics. We have seen that intensity is nothing but an energy flowing per unit time per unit area held perpendicular to the propagation of that energy. Thus, in case of sound, we say intensity is nothing but sound energy flowing per unit time per unit area held perpendicular to the direction of propagation of sound waves. Its unit is watts per square meter. Watts per square meter. And of course, it is a measurable quantity. Intensity of sound can be measured. What is the formula to calculate the intensity of sound? So, intensity is nothing but 2 pi square A square F square rho V, where this A is nothing but amplitude of vibration, F frequency of vibration, rho density of medium, and V is the velocity of sound in that medium. So there are many factors on which the sound intensity depends. A sound will be more intense if its amplitude is high. A sound will be more intense if its frequency is high. A sound is more intense if its density of medium and velocity of sound is again high. So there are many factors that affect on the intensity of sound. This is by mathematical relation. But there are many other factors also that affect on the sound intensity, such as the sound from a bigger source like big speakers is more intense as compared to small speakers. So it depends on the sound of the source producing, it depends on the size of the source producing that sound. It also depends on the distance of the source. Like a source which is far away from us, its sound intensity will be lower one. Sound very close to our ear, its intensity will be very high. The sound intensity it also depends on the presence of other bodies near that source, resonant bodies. If some resonant body is present near that source, the intensity of sound will be greater one. Again, it also depends on the motion of medium. Like if sound source is moving, if sound is moving in a medium in such a way that direction of medium and direction of sound propagation are same, then in that case the intensity of sound that will be heard by us will be larger one comparatively. So these are the factors on which the intensity of sound wave depends. There are many factors that affect on the intensity of sound. Now there is one more parameter that is used to distinguish one sound from another sound, and it is a very well known factor. This is called as the loudness of sound. The parameter loudness is a parameter which is related with the sensation of sound produced in the ear. How sensitive is the sound for the human being? We call it as the loudness of sound, and this is the terminology that we usually use. Sound is very loud, sound is very quiet. So in this way we frequently use this parameter to describe a sound. So loudness is nothing but a sensation that will be produced in the ear. So it not only depends on the source of sound, but it also depends on the listener, also on the ear quality of listener also. But although this loudness is a usually used term, it is not a measurable physical quantity. We cannot calculate loudness in laboratory. But of course, there are few relations by which we can compare the loudness of sound, such that the loudness of sound is related with amplitude, such that higher the amplitude of wave, more louder the sound. There is a direct proportion between these. Loudness is directly proportional to the amplitude of sound wave. The loudness also depends, or usually said to be a next substitute for intensity term. So this loudness and intensity, they are used as the two sides of same coin. These are the same terminologies, like that. So loudness is said to be proportional, not equals to, but is said to be proportional to logarithm of intensity. Thus, as intensity increases, loudness is also increases, but not in the proportional region, not in one-to-one proportion, but there is a logarithmic scale. So, a loudness of sound is proportional to logarithm of intensity. Now, if we know this relationship, loudness is proportional to log I, then if we consider two sources with intensity I0 and I1, two intensities related with, there will be two loudness L0 and L1. So the difference between these two loudness, the difference between loudness L0 and L1, which is nothing but some constant. Why K is there? Because we have removed this proportionality constant. So difference in loudness LD is equals to some constant K, log to the base 10 I1 upon I0. The intensity of two sources I1 upon I0. This term L1 minus L0 or the loudness between two sound waves, this is known as the sound intensity level. Sound intensity level. This is nothing but the difference between loudness of two sources or the loudness of one source with respect to some reference source. Reference source I0. This we treat it as the intensity of some reference source, and usually this reference intensity is taken to be 10 to the power minus 12 watt per meter square. I0 is taken to be 10 to the power minus 12 watt per meter square. What is this term? This is a minimum sound intensity. This is the minimum sound intensity at 1000 Hz frequency that can be heard by a normal person. This is the lower limit of sound intensity that can be heard by a normal young person. So this intensity, that is threshold sound intensity, is termed as the reference intensity. And with respect to this limiting intensity, how intense the next sound is, that is denoted by this sound intensity level. It is the comparison between two sound waves of different intensity. Now, what is the unit for this sound intensity level? It is nothing but the very well known decibel unit. Decibel or bell. This is the unit that is used to measure the sound intensity level, such that 1 decibel is equals to 10 times log to the base 10 S1 upon S2, where S1 and S2 are nothing but the intensities of two sound waves. This decibel unit is not only used in this acoustic field, but it is widely used in case of signals, in case of electronics, in case of communication. So there are many fields wherein decibel or bell unit is used. So the 1 decibel is nothing but 10 times logarithm of ratio of powers from two sources, electric power, sound power, any power. So in case of sound wave, it is 10 times log of intensity of one sound to intensity of another sound. So in case, if we say one sound is 100 times more intense than reference sound, the louder sound, if it is 100 times more intense than the reference sound S2, then the change in dB, the change in sound level is 10 times log to the base 10, 100, that is log 10, log, no, it is log 100, that is 2, and thus it corresponds to 20 dB. 10 into 2, 20 dB. 20 dB will be the sound level. If the louder sound is thousands times more intense, 1000 times more intense, that is 10 to the power 3, log of 10 to the power 3, 3, 3 into 10, 30. So that sound is of 30 decibel, and in this way we can calculate the sound level. So in this way, the threshold of hearing threshold of hearing, that is 10 to the power minus 12 watt per meter square, it corresponds to 0 decibel. It corresponds to 0 decibel sound. 0 decibel sound. Because 10 to the power minus 12 is the reference intensity that we are taking here. So, any sound which is below 20 dB, we called it as the faint sound, such as the sound coming from refrigerator, sound coming from my laptop. We treat it as the faint sound. Any sound below 40 but above 20 is termed as the soft sound. Soft sound. A sound that we usually use during the conversation. We call it as the soft sound. Moderate sound, a sound which is above 40 dB but below 60 dB decibel, we call it as the moderate sound. Loud sound, sound which is above 60 dB but below 80 dB, we term it as the loud sound. Loud sound. Very loud sound, like that of a DJ in a school or orchestra. Very loud sound that may have a sound level of 110 dB, 110 decibel. But a sound which is above 120 decibel, 120 decibel, this sound could not be tolerated by a human being and is said to be the upper threshold sound or the painful sound for human being. 120 dB. And in this way, how decibel unit is used.